Hi, this is Daniel Brown, and I am going to talk about statistics on the sum of two random variables. So our goals are to learn how to calculate the statistics for the sum of two random variables and apply this to a portfolio of two assets. Now, just to recall, for one random variable, we often describe the distribution by referring to the mean, or the average, and the standard deviation, or variance, of that. If the random variable is normally distributed, then this completely describes the distribution. And if the distribution is not normally distributed, then this is not sufficient, but we're only going to worry about mean and standard deviation in this presentation. Now, for two random variables, we have both the mean and the standard deviation. We also have a measure called correlation that describes how the variables are related. And in this course, we're not going to learn how to calculate correlation directly. We're going to use Excel or a calculator to do that for us. So in Excel, if we want to calculate the mean of a sample from a random variable, then we use the Excel function average. And we pass in all of our sample data into average. To calculate the standard deviation, we use stdev.s, and we pass in all of our data. Now there's an alternative function, stdev.p, which is used when we know the entire population of outcomes of the random variable. We almost never know this, so we almost never use this function. But it should be noted that both the average and standard deviation, stdev.s, are not actually the average and not actually the standard deviation, but are estimates of that. Now there's also a function correl, C-O-R-R-E-L, in Excel that calculates the correlation between two data sets. Takes in two arrays, two sets of data, and we can calculate. So here's an Excel example. We've got the mean of the first set, so it's the average of E2 to E9, which is data set 1. The mean of the second set, which is the average of F2 to F9. Standard deviation of the first set, stdev.s, E2 to E9. Standard deviation of the second set, stdev.s, F2 to F9, and correlation, which is correl, C-O-R-R-E-L, and then E2 to E9, the first data set, and F2 to F9, the second data set. Now, we also have covariance, and we define the covariance as the standard deviation of x times the standard deviation of y times the correlation between x and y. Now, within Excel, there's also a function covariance, and there's a .s version and a .p version, just like there was for variance. We will always use covariance.s because almost always we have just a sample of a distribution rather than the entire population. So we can calculate covariance in two different ways. We can either use the Excel function directly, covariance, or we can calculate the standard deviations and then the correlation. Now, for two variables, we're often interested, and the example we're going to go to in just a minute is a portfolio, but we're often interested in a weighted sum of two random variables. So w sub x of x plus wy of y, where x and y are random variables. Now we can take the mean. So the mean of a weighted sum of two random variables, wx, which is the weight of the x variable, times x plus wy times y, is given by mu. Typically, mu represents the mean. So mu of w sub x of x plus w sub y of y equals w sub x times the mean of x plus w sub y times the mean of y. So basically we take the mean of the weighted sum of two random variables is the weighted sum of the means. Now the variance is a little more complicated. So again, we have our weighted sum of two random variables, x and y are our variables, and we have the variance of the weighted sum is wx squared times the variance of x plus wy squared times the variance of y plus 2 wx wy covariance of xy. And of course, covariance is the standard deviation of x times the standard deviation of y times the correlation. We can calculate the standard deviation typically written as sigma, as the square root of the variance. So the standard deviation of the weighted sum of two random variables is the square root of the variance of the weighted sum of two random variables. So it's a fairly complicated formula, but relatively straightforward once we know what it is. And again, I strongly encourage you to learn that formula because we're going to use it a lot as we go forward. Now we're going to do some specific examples here, thinking about investments. Now, when considering investment, one usually thinks about how much risk is one taking compared to the potential return. Now we call the potential return the expected return, and we can attempt to measure the riskiness of an investment by using the standard deviation of the expected return. Now, this is not a perfect measure of riskiness. It might not even be the best measure of riskiness, but we'll use it for now. Now, if we're working with historical stock prices, we often use historical returns to estimate the distribution of returns. So, for example, if we have a set of historical prices, we can calculate the log returns, the natural log of today's stock price divided by yesterday's stock price. This, for some of you, is not the most satisfying version of returns, but it's the one we'll use here. Now, expected return, a first estimate of the expected return might be the average historical return. Now, if we've got daily stock prices, if we use average, we're going to get an expected daily return. Very often, one might multiply that by 252 to turn it into an annual number. So 252 is used because there are about 252 trading days in a calendar year. So in Excel, we use the average function. For variance and standard deviation, we might estimate the variance and standard deviation of our expected return using the variance and standard deviation of the historical data. Again, we might multiply the variance by 252 to take the daily variance into an annual variance, and to scale the standard deviation, you multiply it by the square root of 252. And we're going to use the Excel functions var.s and stdev.s to do these calculations. So imagine we have two stocks. We can consider either the percentage of a portfolio in each stock or the value of the investment in each stock. The numbers are going to come out very different, but we can work with either. So we can either go percentage of investment, weight 1 plus weight 2 equals 1, or the dollar value investment, right? The present value of the portfolio is the present value invested in the first stock plus the present value invested in the second stock. If we know or have an estimate for each stock, then the expected portfolio return is weight 1 times expected return for stock 1 plus weight 2 times expected return for stock 2. In dollars, the expected portfolio return is the present value 1 times the expected return for 1 plus the present value 2 times the expected return for 2. And just note, and a couple of things to say here. One, to go back and forth between dollars and this return, we simply multiply by the present value of the portfolio. Weight 1 is equal to the present value 1, the present value of the first stock position, divided by the present value of the entire portfolio. Weight 2 is present value of the second stock, divided by the present value of the portfolio. So you can quickly see that the expected present value return, dollar return, is the expected return times the present value of the portfolio. The second thing to note is this is telling us how much we think we're going to make. So if I invest $100,000 and this tells me, let's say in dollars, or let's say in portfolio terms, it says 5%, then my expected dollar return is 5% of $100,000 or $5,000, and I expect the portfolio to be worth $105,000, what it's worth today plus the $5,000. Now, we can, if we have historical returns for two stocks, we can estimate the correlation using Correll. We can estimate the covariance using covariance.s, and we can relate them by going covariance.s is equal to the correlation times the standard deviation of the first stock times the standard deviation of the second stock. We can compute the variance of the portfolio as we did before, either using the weights. The variance of the portfolio is weight 1 squared times variance 1 plus weight 2 squared times variance 2 plus 2 weight 1 weight 2 covariance, or using those present values. Present value 1 squared variance 1 plus present value 2 squared variance 2 plus 2 times present value 1 present value 2 covariance. So they work out the same, and we can see the variance of the return and the variance of the present value is related by variance of present value equals the variance of the portfolio times the present value of the portfolio squared. We can calculate the portfolio standard deviation as standard deviation of the portfolio equals the square root of the variance of the portfolio. Or in dollar terms, the standard deviation of the present value is equal to the square root of the variance in present value. And again, standard deviation of present value is equal to the present value times the standard deviation of the return. Now, one thing that we should say here about variance and standard deviation, especially, well, it works for both, but let's think about in terms of present values. The standard deviation of the present value is a number of dollars. And basically that's the units. It's dollars. And so it's easy to see what the standard deviation means. The variance, being standard deviation squared, is dollars squared as the unit. So the variance doesn't mean as much. It's harder to understand the variance than it is the standard deviation. Again, the standard deviation of the return is a return. 3%, 5%, 12%. The variance of the return is a squared return. It's a little harder to understand what it means, which is one of the reasons why we work in standard deviation. Okay, so let's do a quick example. We've got two stocks, ABC and DEF, and we've got a portfolio of $100,000 with 25% invested in ABC and 75% invested in DEF. And we've got expected returns and the standard deviation of those returns for both companies. And we estimate the correlation between the returns at 60%. So we want to calculate the expected return and the standard deviation of our portfolio. So expected returns is pretty straightforward. It's the weighted sum of the expected returns of the stocks. So we do 0.25, that's our percentage of the first stock, times 0.08, the expected return of the first stock, plus 0.75, the weight of the second stock, times 0.1, the return of the second stock, or the expected return of the second stock, and we get 9.5%. So given these portfolio weights, we expect to earn 9.5%. Now in dollar terms, this is $9,500. We have $100,000 invested. We're expecting a return of 9.5%, so we expect to make $9,500. And again, that $9,500, we expect the portfolio to be worth $109,500 in a year. The variance of the portfolio is weight 1 squared times standard deviation 1 squared. Standard deviation squared is the variance. So weight 1 squared times standard deviation 1 squared plus weight 2 squared times standard deviation 2 squared plus 2 times weight 1, weight 2, standard deviation 1, standard deviation 2, correlation. The variance is 0.048906. The variance in dollar terms is $489,062,500. So it's a somewhat meaningless number. We can convert to standard deviation by taking the square roots, and we get the standard deviation of the portfolio is 22.115%. So sort of, this is a measure of how much we can be off on a return. And if the return, the expected return is 9.5% with a standard deviation of 22.11, we can be wrong by quite a lot. And if we take the standard deviation in dollar terms, that is $22,115. The 0.22115 times 100,000. And that standard deviation in dollars terms starts to, for my portfolio, I expect it to be worth $109,500 not plus or minus 22,115, but the standard deviation. This is a measure of how wrong can I be? Now, we will talk later about applying the normal distribution to this so we can think about probabilities. But for now, we've calculated the variance, the standard deviation, and the expected return for a portfolio.